So I am Irfan Ahmed, and I am the executive director for the Center for Nanoscale Science and Technology, which is a collaboratory. By what I mean is that it brings together all the nanotechnology research on campus, and including some of the labs and centers which exist or conduct nanotechnology research. That not only entails research but also education, training, entrepreneurship, and outreach activities. And I was inducted and hired for the Center for Nanoscale Science and Technology to be the bridge builder between the Colleges of Agriculture and College of Engineering in bringing to fore the overarching biological, agricultural issues, problems which engineering may have solutions to or would have. The community is making steady headway, but it's not at the pace that some would like, and especially if you are a patient and you would like to have some solutions today. To me, I mean, we can see this right now going on with the healthcare issues in the nation and the issue of millions of fellow Americans not having health insurance while being the richest country in the world. So some would say it's the best of times and it's the worst of times. So it's the best of times for those who have it and for the worst of times for those who don't. I would hear all these heart-wrenching stories, and that really moved me to that there's an area that needs attention, not only my attention, but I mean most people's attention, and especially engineering solutions to some of the medical challenges. And that's why you see that the National Cancer Institute actually started these programs which are called Cancer Nanotechnology, and that is exactly the reason that you use nanotechnology for reducing the suffering from cancer. You're talking about the convergence of biotechnology with nanotechnology, and whenever we introduce the word bio, that means handling of soft materials, and that would entail you name it. I mean, so for agriculture, food, medicine, environment, anywhere there's a biological phenomena. In this case, we are focusing on engineering and medicine, and it's a large area to cover. But we think that at this campus, we have the resources and the intellectual firepower, so to speak, to conduct some of the outstanding issues confronting us both in this country but globally too.
My name is Brad Deutsch. I work in the CISL group, that's Chemical Imaging and Structures Laboratory. The PI is Rohit Bhargava, and we're at the Beckman Institute at the University of Illinois at Urbana-Champaign. Our lab is in the business of making images with microscopic resolution that also give you chemical information. If you can make a map of what kinds of tissue you have everywhere, you can supply that as extra information to pathologists in diagnosing cancer or other diseases. I think everything in there is off the shelf. I can't think of anything we manufacture ourselves. But yeah, you buy an infrared source, which is just a crystal or a polycrystalline silicon carbide rod, run a few amps of electricity across it, and it heats up and glows. So that provides the light for the experiment. We have a couple microscope objectives to focus down on samples. We have a mirror that's attached to a moving stage, where you just tell the stage, go 5 microns backward and it moves. We have a beam splitter made of barium fluoride, which is transparent in the infrared, and then we have a detector, which is liquid nitrogen cooled, which is sensitive to the mid-IR region on the spectrum. I think this work will appear invisible to the cancer patient, him or herself. what will happen is that fewer mistakes will be made. Maybe we change it by 1%, maybe we change it by 10%, but change the accuracy of that diagnosis. And so if we can change it by 1%, that's still a lot of patients in the US every year, for example, or in the world every year, that can be helped by this.